about these things.
You should continue.
You can continue. All right. If you're gonna stop me after every second slide, it's gonna be a nightmare. So for the online people, there's a slide you saw, begin foo and foo. We can go on. I didn't say anything super useful except read your slide. Here.
One problem with slides.
One problem only?
I hope it's only one. It's good.
I think I gave thanks to Vojta too early. He made the monitors work. Or he's looking for more thanks or something like that.
Everything. Okay. And camera. Give me a sec. Okay.
Okay, it suddenly disappeared from over there, but I don't care. Oh, it's back. I'm off again. Interesting. Now it's blinking. Okay. So we're online with the slides. Somebody can check the stream or something, please. Thank you. Alrighty, apologies for this delay. As you see, now we don't have slides, but we have a live feed of the camera of the slides, and we didn't get farther than for the behind the first slide, so you didn't miss out much in history and everything. Anyway, so let's go on. APM happened, you know, pretty popular. You've seen it around. You've seen it like this: begin foo, end foo. And the synchronous call of the same thing would be, for example, send, like on sockets.send, and there would be sockets.beginSend and sockets.endSend. So if you would achieve the same with the asynchronous method, this is what you would do. You would basically pass null null and call the begin, result immediately passed into end, and the end of foo or something would just block on that thing to happen. Obviously, that's not what is meant for. Like you don't need the begin and end methods. And to really take advantage of the asynchronous nature, you call the begin of something foo, and you pass the iasync result, method IAR, and inside the callback you actually call the end foo, because that's like you're gonna be invoked when you're done. You're supposed to call the end foo to kind of find out what the result of the async operation was, and then you can do more stuff with that. Seems pretty straightforward and simple, but well, in reality it was not quite more useful. Because if you started doing anything interesting, for example, super interesting thing when you're copying data from stream to stream, like we do it all the time. Over here there's a code. You basically have a loop when you read from one buffer, basically from one stream, not from buffer, but you read buffer from one stream, and until it's 0, you take it and pass it somewhere else. Imagine from network to disk or something like that. Fairly simple. So if you do that in the loop, how would that look like with the APM, right? You would, in the same thing as I said, you would do the begin read of like reading from the network or something, and you would create the function inside, like the callback that kind of calls the end read. Cool. After you read it, what do you want to do the data? You want to write it out, probably in asynchronous way. So you call begin write, and inside you again do another callback, which starts with end write. And then you do interesting stuff. What's the next step? So you just copy the first buffer. So you do the next one. So you read the second one, and then you write it out, and again, and obviously you don't know how deep it will go because, upfront. So that's not quite scalable. Now, interestingly, apparently, I've been told you can write this in a loop. It's extremely tricky, and only a few people get it right. And to make things even more, interesting and things, this thing does everything purely asynchronously. It doesn't optimize for the case when here and there, because you, for example, read lots of data, you don't want to read things only synchronously and kind of like go into another thread pool and whatever. You want to end immediately. So on next slide, we're gonna look at if the kind of how it kind of is complicated with this completed path. So this is how it would look like when you kind of want to optimize, for this completed synchronously. So in the callback, you would basically check like, hey, if this has been not completed synchronously, which means the callback is true callback and you should do the work, then you do the, interesting thing we have just seen. And after the call of the begin read, you would just check like, hey, by the way, did this finish immediately? Because maybe the data was cached, available, right? Maybe you're reading, from via memory stream, and you get lots of data, and then you read byte by byte. So typically you get the completed synchronously immediately because everything is in memory. Now, if you do that, that's what you would do, and you would basically have very similar code path in both places. Now, turning this into loop or kind of cycle is extremely difficult. Again, even more complicated than the previous one. It's very complicated, and practically people just gave up and said like, whatever, I'm just gonna queue things on thread pool. It's much simpler. Why the heck do I kind of deal with this? Which kind of defeats the purpose of the asynchronous. Or well, it's gonna get you something, but it's not quite thing that we would want to do. Now, because it's complicated, there's actually apparently in BCL, especially in our networking, for example, there's lots of kind of various wrappers around this and making it kind of more convenient to use actually in the loops. And we have such specializations, but again, like it's complicated, nobody wants to touch it. So we made another effort. EAP, event-based asynchronous pattern. It came up in .NET Framework 2.0, which I believe is 2005-ish, something like that. And apparently we shipped something via the event handlers, right? Events. It looks nicer, like you kind of subscribe to the event, it gets kind of invoked. The trouble with this approach is that actually it did not solve the multiple call problems. So we created something different without realizing that it has exactly the same problems as the begin-end pattern, which there goes, kind of the, decision like, first ship it and then realize actually if it's useful. So this was not. We actually use it in BC on a couple of places. SMTP mail, TCP client, background worker, a couple of those things have. The interesting part why I mentioned it actually that this pattern actually introduced as well execution context, which is something that survived until today because it kind of handles the thing and carries the data alongside your kind of asynchronous call wherever you jump. I'm not going to talk about that more because I don't know much about it, but might be probably its own talk actually about execution context and what's happening over there. So yeah, it's a great lesson to not ship something before you realize actually if it helps people. We now have to live with it. And the next thing that came after that was actually Task. So interestingly, it came in .NET Framework 4.0. And interestingly, actually, it originated in a MSR, which is Microsoft Research Project, which was focused heavily or only on parallel computing. So it was basically the divide and conquer, imagine quicksort, when you have you just split it in parts, say hey, you do left side, you do right side, and then we will merge the results. And this thing actually shaped the task to the way it's today. Which is interestingly that, as Stephen called it, which scares me a little bit, is that 90% of the task was done right, and 10% still sometimes wake him up in the night and he can't sleep. And he would love to get rid of that, but because we're .NET Framework and .NET Core, we are nice people, we don't remove APIs, we don't break people. I mean, we try, you might be broken by us sometimes, but we really try not to. Anyway, so what is task? It represents really kind of general work. It can be compute, I/O bound, anything. In other languages, you have terminology like promise, future, or whatnot. The key thing is actually it's not tied to thread pool. So it doesn't know anything about thread pool at all. It's really just like, something happened. Inside what it has, it's either task or task of T, in case you return something, or, the task stands for void, basically, because void is not typed, so we cannot do task of void. And what it contains are actually things. Either the T, the result, if it's task of T, it has some state related to some synchronization and stuff, and as well state related to the callbacks. But let's look actually what other thing, which is task and task completion source. Those two things kind of work together. So task is something that you can consume. You get task and you can kind of hook up to it. You can tell it hey, here's a callback. And when you're done, or if you're already done, just call me back, right? Another option that you can do on task, you can wait. You can basically say hey, dear task, just wake me up when you're done, which may be right away, or it can be a little bit later. And the key thing that you cannot do it, that you cannot, you as a user, if you get a task, you cannot modify it. You cannot kind of say you're done. You're not the author of that. And that's the interesting split between the task and task completion source, because task completion source, that's the magical thing. That's the source of when the task will be completed. And it's basically a wrapper around task. So internally it holds task. And because it's the same assembly, it can use internals. And it calls on task methods like set result, set exception, or set canceled based on what you want to do. But basically that's the only body or other type that can modify the task. And the thing that kind of helps, alter that, you don't want usually you don't want to share the completion source with others. Because imagine you're reading something from the disk or from network, from somewhere. There's no reason for you to pass it along to somebody else and tell them you know what, you decide when it's done. If you originate something, usually you are the person who wants to say when it's done. You want to be in charge. However, what you pass around is exactly the task, so kind of the inner thingy. You throw it away hey, go, because the only thing you can do with that is hook up to when are you done, wait on it, and that stuff. That's what you pass around. So, how do you consume it? Let's look at some code. Imagine, if you have task T, you can either, as I said, wait on it, so do call something t.wait, or you can call t.continue with and pass it a callback. the interesting kind of mental shift and what's kind of really interesting on the task is, if you notice in the old APM or even in the EAP, we pass the callback at the creation. The beauty of the task is that whoever creates the, like, hey, I'm done, doesn't say what's gonna be called after. You pass it around, and whoever, kind of the consumer, later on hooks up, like, please give me the callback. This is the way how you hook it up. And that's why actually task is so powerful and doesn't have the problems of the original thing, where at the creation of the asynchronous event, you had to know what to call back, and that messes up things and kind of makes it basically unmaintainable, unusable. The interesting thing that you can actually call it multiple times. So you can register multiple callbacks that will be called, and there is no guarantee, in order of execution. So which one goes first and that stuff. You just know that, when the right time comes, they will be called exactly once. And it's always asynchronous, even though it can be queued, and it's queued to the thread pool and schedule. And I think there's a way how to make it, how to do it synchronously with some kind of specific options which are not interesting. So the beautiful thing of the task is to kind of generalize the reusable part of the asynchronous, and you could hook up to it, versus in the AMP, we really with iasync result, we really didn't have something that kind of could be shared implementation, because you had to kind of put the callback immediately into where you created the stuff. So whoever kind of decided to read from network or whatnot had to know what's going to be done with that later on. And this beautiful thing enabled something like async-await and like how it works, which we're going to get to. But before we do that, we're going to do some thing like, this is the thing that keeps Stephen up in the night. We did a beautiful thing which you probably who have used Task.Run. All right, 10, 5, 7, 10 people. Okay, more. Yeah, you're ashamed, right? Anyway, the thing is that it complicates things. Why does it complicate things? Because it actually ties the task to thread pool. Even though I said task has nothing to do thread pool, it's really general thing. The task.run basically says like, yeah, but mostly you need it on thread pool, so let me be helpful for you. So the task.run gets a delegate, which means at the creation time, which is interesting, and adds, as a result, actually, it has to add field into the task, mess it up, and queues it into thread pool. The kind of thread eventually kind of grabs it, executes the work, and marks it completed. But it's kind of like this convenience thing. It sounds useful. The thing is that there's a super simple way how to actually implement Task.Run on your own, which we should have done and let everyone implement it or have an extension method or something like that. We didn't. So we complicated things. And actually it's a great example as well how to use tasks. So let me run through the code. So this is the Task.Run. You get the delegate, or over here it's called function F. What are you going to do with that? You're going to create a task completion source because you're the one doing the asynchronous thing. You're going to queue the work item on the thread pool, and when that thing will basically execute the thing that you were supposed to do asynchronously, it's going to get the result, and then you're going to use the task completion source, because that's the only thing that can kind of set the result or change the thing to kind of set the result. Pretty clear, right? What are you going to do out of this? You're going to return the task, which is hidden in the task completion source. And to kind of be nice, you're going to do some kind of try-catch. Fairly simple code, beautiful extension method which is burned into task and makes it a little bit less nicer and a little bit ugly. Anyway, we live with our mistakes, such is life. So how do we use all this to kind of implement something like async-await, which is the interesting thing. Async-await pattern came in .NET Framework 4.5, C#5, and typical asynchronous code would look like that you would have, for example, a method like get data async from somewhere and put data async somewhere. The code would then look like this, like you would take the task, get async, or without the async await, like how would you use it? So let's say you want to do the same thing. You want to read something, write something, and then print out I'm done. So you would get the data from somewhere, read them. Then you would hook up the callback where you would want to see like, hey, when you're done, let's actually take the result and write it somewhere else. And when that is done, let's hook up something that will say, I'm done, console. that's kind of, you know, ugly. It basically looks like the async result thingy, and that's not what you want to do. Or well, you know, actually it's easier than that, but you know, it's still kind of ugly that you have to write everything in so explicitly tailored. So the async-await, what it does, so this is the same code, is actually magically generate, you know, compiler magically will generate these things for you. So it will, you know, what you're gonna do, you're gonna call the get async data, you're gonna read them, then you're gonna say just await on that, magic happens, you're gonna get result, and you're gonna put the result back there again, you're gonna await the the task that you got, and magic happens. When it's done, you're gonna write down, you know, I'm done, which is more kind of fluent for developers. From the perspective, you kind of know consequently how things are looking. You don't have it kind of hidden in some kind of callbacks and whatnot. And when you look at the code, it's easier to reason about. So how does this work? Now, the interesting thing is that, you know, compiler to generate from the await and async, you know, async combo to generate the code above, which is like, you know, something you have to use the task on. The compiler could have done and hard-coded everything and say like, hey, if you see task, do this and do that. They were smarter. They actually used the duck typing and the so-called awaiter pattern, which basically looks for something that looks like task. By the way, I'd never understood what duck typing is. It's like, why would anyone do such thing as look like this? But this is super powerful. The only thing basically you say, it's almost like interface. You basically look, you know, hey, if something behaves like this, let's call the right methods and let's be done with that. So let's look actually how the awaiter pattern behind this actually looks like. So simple thing, if you have await on a task and you get result, actually it's translated into, you know, in the compiler really, when you look at that a little bit simplified into something that on the T, no matter what it is, you basically call, you know, look for something called get awaiter. And on the get awaiter, you need to have something called is completed. If it is not completed, then you do asynchronous parse, and once it's done, you do some magic, which we're gonna look at a little bit later. Once it's completed, you're gonna call on the awaiter get me result, and either it returns some the T, or if it's void, it just like returns and it's done, or it might throw actually exception, as you see, and that's it. So the bold methods, the free, the get awaiter is completed and get result. Basically, those are the things we're looking for, right? You know, so the T has to have the get awaiter, and get awaiter has to have these two methods, which kind of satisfy some things. So let's actually look at more how it looks deeper. So let's look at the same code. So we have the if not awaiter is completed, and we're gonna return eventually the result. And all this thing is actually encapsulated in a method on something, we're gonna go into that later, which is kind of move next. Because what do you have to do? Overall, it has some kind of states. Sometimes it comes back, and you jump into basically a state machine. You jump to where you are. So in this particular case, in this particular piece of code that we already had, what are you gonna do? You're gonna say like, hey, let's say this is state 42. So you're gonna make sure, save somewhere. This is where I was. This is the state, which is on the larger object. And you're gonna call on the awaiter on completed, which will basically say like, hey, once you're done, call this move next on this object, and we're done. What are you gonna add for? When you called as move next with the state 42, you're gonna say like, hey, I would like to resume the continuation of this method after the not completed thing. So you're gonna basically come back to the like, hey, we now have the result, the label 42, and you can call the get result. So all the if statement under the not is completed is going to allow you to kind of like sidestep, leave the method, and then resume the flow, continuation, execution wherever you were there. And all these things again, like is pattern matching, is in like on the awaiter. It's just there's not specific class that compiler looks at. It just expects that these methods are there. If they are not there, it's not gonna use that stuff. So how does the state machine look like? That's basically the object or whatever was encapsulated in the move next. So let's look at something called code with await. Like imagine that you read something from user in a string, and you await some task for reasons, and then you want to say like, hey, I'm done, and write down whatever you read from user. So you've seen that the await will basically make this kind of break in there, right? In the execution of this method, it's going to kind of step outside and come back to the move next method. But what's going to get really inside? So the state machine will be really called for this method foo, let's say, method foo state machine, and we're going to have the move next method, which we looked at, and we're going to have stored things which might be needed. Some of them are locals. So for example, the X over here, because it needs to survive the await call, it's going to be captured. It's like in lambdas, very similar thing. And all the parameters of the methods, if they are used across the await boundary, they're going to be captured over there. And there's going to be obviously the awaiter that we have seen being used and the state itself. So this is roughly the thing that you're looking at that. Compiler is smart, so imagine that you didn't use the X across the await boundary. In that case, it would not be captured as a local in the state machine, because why to capture? Now, notice one thing, that this is actually a structure and not a class. Why is it a structure? Because basically on each call, so whenever you call await on something, which can be reading just one byte from a buffer, if it would be a class, you would have to, on the heap, allocate one object. That's quite heavy toll. So the thing is that actually it's structure, so it's going to be only on the stack, just reserve some space, use it, and everything passes around. You don't need to kind of allocate that, which is beautiful. Interestingly, actually in the debug mode, what compiler does actually changes the struct of these state machines to classes, because when they are lying around and when you debug things and you break into things, you actually want that stuff for debuggability. So in debug mode, you're going to allocate like crazy. So don't profile your applications in debug mode when you're using async-await. Bad idea. In general, bad idea, but it's super important over here. So optimization structs, again, like, for multiple calls, you're going to get the savings. So let's look at some example of the state machine. How would it look like? Imagine you're doing something simple. Foo method, which is marked as async. By marking it async, you're basically saying like, hey, I'm allowed to use await inside. It takes some time out, and it's just going to call, hey, wait for the time period of time. Fairly simple. So how does the state machine for that method foo will look like? So it's going to keep the parameter, the timeout. There will be locals. Over here, we don't have any locals in that method, so no reason to kind of capture anything. And there will be the move next method inside. Then, as I said, state and the awaiter itself, which, because we're dealing with task, would be task awaiter in this case, of that type. Now, what the compiler actually generates? So it generates the state machine, and it replaces. It doesn't use exactly the foo method, but it generates another method, which returns task, same structure, except it doesn't have the async. That's just the compiler goo. And inside, what it's gonna do? The first, you're gonna create the state machine as a default structure. You're gonna set information on the state machine. So for example, the timeout, you're gonna start with 0 state, that's where we start, and then you're gonna do, hey, do the thing, move next, execute my method. And then it's gonna return something. Now, let's look a little bit more what it's gonna return, because it's gonna be task and how we get to that. And we're gonna look into more details actually what's in the foo method. So the same code, that we have seen on the previous slides. We created a state machine on the left side, state machine is on the right side. So what's gonna be in there? In the move next methods, in the move next method, as we've seen, in previously, we're gonna have to on the TaskCompletionSource. That's the kind of thing that kind of is on the state machine that's kind of encapsulating the task. We're gonna set the result. The move next method basically eventually is gonna say we're done. When your method basically does the result, and that's exactly or what we need as well in the foo method is to allocate the task completion source and eventually return the task from inside. So over here we have the task completion source, which is again like the encapsulation of the task. That's the producer. That's logically that's gonna change the state machine. And while I've wrote the task awaiter or the task completion source, that's already hard-coded type. Again, that's not the specific thing, because that's gonna be there. We're gonna look at that because this code has two problems. Or imagine that the foo call, like you call it, multiple times, and let's say that's again like you're copying 10,000 10,000 bytes, or something is read into memory stream. But in each call, you just copy 1 byte. What's gonna happen is that in each call, you're gonna allocate. Now the full stack machine is structured, beautiful. It stays on the stack, nice. But you're calling new on task completion source. That's one allocation. What's gonna be inside the task completion source is the task itself. So you have 2 allocations per each call. Imagine for each byte read, in a loop, you're gonna do 2 allocations. That would kind of suck. So in principle, this is what's there, but in fact, the code looks actually more complicated. So instead of the allocation of the task completion source, which is associated with the task, what we're gonna do, we're gonna actually, the compiler is smart. It's gonna look at the task, because that's the kind of duck type thing. So like, oh, you look like something that I should deal with. Who's your buddy? Who's your builder? And it's gonna be, in this case, actually I use the ValueTask builder, and it's gonna call create method on the builder. So instead of that, we use it heavily actually in the ValueTask, which we're gonna get later too. And the interesting thing that the create on the builder, because we're gonna replace it with the new, that's a thing that can actually return a structure. So it doesn't have to go on the heap, it doesn't have to allocate. It can go, it can be a structure which can be kept around, and that's gonna save us 1 allocation. So instead of the task completion source, obviously you're gonna keep the, it's not gonna be the task completion source, it's gonna be the builder, which is some type, and you're gonna have the task inside of that. So this is how we will get rid of 1 allocation. So how can we make it even better? And how we make it even better? How do we get rid of the task allocation? How we keep it as structures and not everything on the heap? So first of all, the builder can be smart. It can reuse known tasks. So imagine that, for example, on the task, if you don't return any value, there's an information completed task. So you can reuse something like that without any value. You can reuse, for example, values on Boolean, because you have only result of true or false, so one of those. On integer, there's kind of more results, but practically actually we found out, or what we cache is some numbers from -1 and 8, because they are probably very popular. Sometimes you can actually do what you can cache is like, hey, what was the last completed task? Because imagine something like memory stream, or any streams. You usually copy in the same chunks of byte until you come to the end, which might not be aligned. For example, 4K or 10K, whatever. So once you go in the loop and before you finish the copying, you can reuse the same number, because there's the number, let's say 4,000. So you can kind of instead of like doing many allocations per each call, you can do 1 and use the cached value. Now, that, for example, doesn't work in certain scenarios, because then you have scenarios like SSL stream, with HTTP, when you have the headers and then you have the body of the HTTP. Typically, those sizes are very different. Like the headers are very small, body seems to be either super small or super large, depends like when you store your things. But it kind of alternates. So, in theory, you could maybe cache last 2 completed tasks and kind of guess if they're gonna help. But it's all a bit complicated at the point of view. The other actually perf improvements, if you look at that, or why perf matters, like the size is 64 byte without value, or 72 bytes of the state machine, kind of the overhead without capturing anything. So, of the task itself. Now, it's okay, and if you have Azure workloads or whatever, GCC will eventually collect it. But if you look at the hot path, like if something really goes quite a bit, you probably kind of pass things around, like you're some proxy or something like that in Azure, or just have a code hot path. It can actually attribute up to 5-10% of your performance. How? Not directly, you would immediately see that, but eventually from time to time, GCC have to all these kind of allocated objects collect and throw them out because they're not used anymore. So how to prevent that? So what we did and created in .NET Core 2.0 quite recently was ValueTask, which is actually a structure. And we leveraged the beautiful thing that we didn't hard code it compiler like, hey, task, this is task and this is task completion source. We said like, it's something like task and it has something associated that looks like task completion source, the builder. And we were able to actually release a NuGet package that basically announced to compile like, hey, I'm the task-like, so you can treat me like task. So we didn't have to go and change .NET framework. We just released, and to compiler teach more things and have new compiler. Instead of that, the compiler just naturally lit up. So that was a huge advantage. And what it does that inside the value task has actually two options. Either it carries the value, or in case it's really asynchronous, you cannot finish immediately, it captures the task of T, or the task that it needs to wait for. And all the methods are actually kind of one-liners, because the value task is the fields inside. Either one of them is null, the task, and then the T is the meaningful thing, or the T is default because it's a structure, and the task of T is non-null. So one of them can be kind of valid, not both of them. And then all of the methods basically look like that. They look probably at the task and say like, hey, task, are you null? Okay, if you are, let's use T. Otherwise, go this path. Otherwise do that. So it's kind of very simple, kind of a wrapper almost. Logically, it's easy to read. Now, the problem is with the value task is that we, if you have methods and things, you would love to do something like read of async on stream or something, return the value task. But it's overloading on the return type, which is not supported. And actually, today I learned that apparently it is in latest version of C#. So I'm going to have to change my slides. But at least in .NET Core that is out there, I believe in free, .NET Core free, .NET Core 2.1, the C# compiler for that below 8 actually doesn't have overloading on return types. And because of that, what we did actually was tricky thing that we used the fact that we introduced as well memory stream and span. Who have heard about memory of T and span of T? A little bit. So it's kind of reading native memory or looking at memory directly, including native, and kind of almost being C++-ish, getting C++-ish performance without the lack of safety with some guards, which is kind of beautiful. And because we added that, and for performance, many of these things, instead of allocating byte arrays and whatnot, we wanted to kind of add these overloads. When we added the overloads, we actually said like, yeah, hey, we're adding this overload, let's return the right thing that is kind of performance cool, which is value task, which introduced some, interesting, weird thing in the PRs in CoreFX or now in .NET Runtime. When you see the, sometimes you see comments, especially from Stephen Taup, is like, hey, you're passing here byte of arrays. Can you, to this, for example, read async, can you just create new memory or new span of byte over, new memory of byte over the byte array? And people ask, why would I do that? Well, why would you do that? There we go. We just lost sight. Don't touch it. Go sit down. I don't want you here. Okay, thank you. And people often ask, why would you do that? Why would wrap this byte array that I can normally pass? There's an overload. Well, the beautiful thing is that if you wrap it in the memory of byte, which is I think it's a struct, so it's free, it's very cheap. You're gonna call the right overload, which is gonna do value task. And in case that you're really calling things synchronously, it's not gonna allocate anything. So overall, better performance. Obviously, whenever somebody looks at code, like that's what they do, right? Now, the interesting thing with the task versus values task, that our guidance is, the value task is kind of harder to use, and really, it should be used only in places where are really hot path and perf sensitive. So, if you now wonder, like, value task, this is what I should use, like, really, don't make things complicated for yourself. Use just the task. Only in case that you're really hitting kind of the hot pass, which in BCL, on the .NET team, obviously, we had. What did you do? All right. On BCL, we have actually, sorry, what was my train? I lost train of thought, like, when these things are swapping. Yeah, it was very important stuff. Yeah, we use ValueTask quite a bit, the overloads, because like the functions we deal with are often things that are on some hot path of something, like copying string and things, or streams or stuff, or actually networking I/O. We have workloads, we have customers who actually have workloads which are networking heavy and whatnot, and they value whenever we can kind of shave off one allocation here or there. So you would say like, cool, we just got rid of the task allocation with the value task, especially, well, we got rid of it in the synchronous case. There's still the task inside the value task in the real asynchronous phase, if something has to wait and block on something. Can we improve it more? One would say probably not, and it's kind of like, apparently it's like pretty rare, like let's say like 1% of asynchronous calls cases. Can we improve that? Turns out that we can. And in .NET Core 2.1, we introduced actually we actually completed the value task and introduced actually third option in there, which is ValueTask-Source, which is very similar, like you see the task source, that's exactly very similar to what we called before, like, it has pattern, like, are you completed, you can hook up something and get a result of something. And that interface can do whatever it wants with things. And then, again, on the value task, it complicated a little bit the code, that instead of saying like, hey, dear task, are you null? Okay, if not, let me call this branch otherwise. Now there are three. You basically look at, hey, I value task source field. Are you null? No. No? Okay, go execute, otherwise task. Are you null? No. And then you have the third option. So it's still fairly straightforward. The interesting thing really that it kind of enabled, and by the way, there's similar thing for the value task without the T, which before we didn't need, because the value task without T never has the T as the option. So it had just task, so it's useless thing. But now we had to actually, bring it up and have it make it meaningful. And the interesting thing on this, that the interface, I'm going to go into too much details, but actually inside it can actually do things if it knows, and reset the results, the tasks, and reuse them even more. For example, but you need kind of more information about what's happening, and you need to have extra guarantees. A great example is on sockets. On each socket, each instance, you can either send socket. If you want to send another, you need to wait. You cannot send in parallel. Like, how would it look like? Like, hey, I'm sending in parallel. You basically serialize sends. And the same way, you serialize reads or receives. So what you can do, you can basically allocate one object for the result, for the one send, and when the send is done, you can reuse the object and use it for the next one, and next one, and next one. So you have basically zero allocation, even for the purely asynchronous code path in such case. It's used in pipelines, channels, and networking stream. Kind of neat, But again, the key thing is that value task, like this is what kind of makes the value tasks, complicated. You have to be careful. You have to have the extra guarantees. Suddenly it kind of feels that you're in the C++ land again. Like, you have to kind of really know what you're doing, and that's why we recommend, like, stay away from task unless you have the business need. You know that it's gonna pay off by the perf improvements for what you're gonna get out of that. So in summary, what have we learned today? We went through the through the APM pattern. That's the asynchronous programming model in the .NET Framework 1.0. There was the begin foo and foo, and the problem with that you had to pass the callback at the creation time, and basically limited your option how to nest things, how to do loops, and it's very complicated, especially with the synchronous path. Then we created a great thing, event-based asynchronous pattern, which is basically the same, except that it uses events, but doesn't solve any of the problems. The next step was task, which has the thing that you can either wait on it, or you can hook up your own callback, which is continue with. There can be more of them. And it has the pair of TaskCompletionSource, which is something that's gonna really kind of control the task and tell the task you're done, or you throw exception or something like that. The task is purely consumer thing. On top of Task, in the next release of .NET Framework, we created the async-await pattern, which used the awaiter pattern. So, hey, I'm looking for something task-like and task-completion-source-like. It has state machines. It generates lots of code that you now fully understand with lots of go-tos. Probably the only place we should ever use go-to in C#.
Okay, we are online.
Okay, so I didn't really know what to call this talk. It was going to be accessibility in 10 minutes or modern web accessibility. I don't know. It's just a sort of general introduction to this maybe, and some thoughts about our experiences and what we've done. I feel a bit of a sort of imposter here after the async-await. I mean, my background is Java, and last time I did this, it was a runnable interface and things like that. So I'm afraid this will be a sort of a different sort of more touchy-feely sort of type talk. But anyway, so just to start off, who's actually doing sort of front-end development, sort of things which the user actually interacts with? Okay, cool. And how many of you are sort of actively thinking about accessibility when you're doing that? So yeah, that's pretty much the usual story. And there's lies, damn lies in statistics, but people generally say there's about 1 billion people in the world who have some difficulty using the web in the traditional way, or some disability. And what we have to consider is that that's not maybe all the time, but I know at one stage I broke my right wrist. And if you try and use your mouth with the left hand, it's pretty damn difficult, yes? And so for that period of time, you have some sort of impairment. And probably you want to actually use the keyboard to navigate through your websites. And so these are the type of scenarios which we need to make sure that we're actively supporting at all the time. So many people have been telling the story that unless your website or your application is accessible, you're losing about 20% of your business at some point in time. And that's pretty significant, and you thought everyone would say, oh, 20%, that's pretty big, I ought to do something about that. Well, people probably haven't. No, most of you haven't really spent a lot of time investing in the accessibility websites. And I think that's about to change. And it's about to change because of this. So, Mr. Rubles tried to order a pizza from Domino's Pizza in America. And he tried on his mobile app, and he could perhaps do the first few things. Then he tried to select the toppings, and he just couldn't on the mobile app. And then he tried the website, and he got some way through the website, and again, he just could not complete his order. And so, being an American, he did what Americans do, and he called his lawyer. And basically, this has now gone through the lawyers, and it went up to the Supreme Court. And the Supreme Court has told people that websites and applications, just like your Domino's Pizza presence, need to be accessible for people who have disabilities. And this isn't quite over. There's more legal wrangling to sort of go through. But this is a big wake-up call for really websites and applications everywhere that they really need to start making a difference and really actually considering accessibility going forward. So, there are lots of kinds of impairments which people have, and you don't see them a lot of the time. I'm actually very slightly dyslexic. I find learning language is difficult, and The spell checker, the technology of spell checker is my best friend. That's really come to my rescue. You also need to think about disabilities aren't always there all the time. A lot of them are temporal, yes. And most of you are fairly young in the audience there, but I'm getting to the sort of second half of my life, and I'm beginning to realize I'm not preparing myself quite as quickly as I used to. Yes, and I can imagine the time when I will start having difficulties with eyesight and things like that. So the stuff really is for everyone, and it's probably for you at some stage in your life, when you break your leg, when you have cataracts or something, yes. It's for all of us, and we need to really think about the different aspects of it. So, technology really sort of comes to the rescue, especially for visual issues with the web. And we look at a visual representation of what's on the screen, but actually there are two representations of the information on particularly a web page, but also a little bit also in applications. There's what's called an accessibility tree, and that's a sort of alternative view of how the web page is represented. It's about the active elements and the elements which you can interact with and so on. And there's a system of technologies which can read that and display it or convey it in different ways to the user. For visually impaired users, the most common ones are the screen readers, and there's a sort of variety of screen readers. And what these do is they basically produce an audible version of your web pages. And if you actually watch people with visual disabilities using these, it is utterly amazing. Just find a YouTube video of someone who's using this at speed. The audio sound is so quick, you won't hear what it's saying, and they're listening to it, they're responding to cues, and they're just pressing keys on it and navigating through pages really amazingly quickly. The good news about these screen readers is they're getting better and better. The bad news is they're still different. So getting things to work across a range of screen readers is still particularly hard. But this is a sort of amazing set of technologies which help people a lot. So with 10 minutes, I'm not going to sort of teach you how to create accessible websites or accessible applications, but what I'd like to do is just give you some thoughts about some of the lessons which we've learned around this. There's sort of three main things which are sort of on the slides and sort of not. The first thing is you need to think about it early. Just think when you're thinking about what your web page is going to do and how someone could get the information from that page without being able to see it visually. Yes, just consider that and how they would navigate between the elements of the web page. The second thing is your assumptions about how they're going to do it are wrong. I mean, they might not be wrong for everyone, but they'll be wrong for a significant portion of the people who are going to use your website. So you may think it's completely obvious that the person needs to move with arrow keys between these items, and they will say, I never ever do that. I would just use a shortcut. Or your assumptions about how people are going to do these things are going to be wrong. You are going to need feedback from real users who are using this before you get anything which is actually usable. And the third part, which is sort of where the modern web accessibility comes in, is don't ever try and solve this at this particular bit doesn't work. You need to try and solve this at a higher level. You need to use components which are accessible in themselves, yes? If you try and design every single little control yourself and do this, it will not work, yes? You'll be in a nightmare of bug fixing forever and ever and ever, yes? We have to try and move the level of abstraction of what we're trying to build a little bit higher, so that we're not building individual drop-downs, and making a drop-down accessible is actually really hard, yes? Let someone else do that work. You try and use those accessible components and put them together in a way which will actually work. and test. This is the other area where things have really changed radically over the last couple of years. Really, 2 or 3 years ago, there was really very little testing available. There was, maybe you could check for high contrast in your icons or something like that, but beyond that, there wasn't really very much which was actually useful. There's now a range of tools, both for the sort of desktop applications and the web, which really do help. The one which is, I mean, it is a Microsoft product, but I'm not particularly plugging it because we're here. It is just really very good, and it works in a number of different ways. This Accessibility Insights is free. You can download it and use it, and it really gives you meaningful results. It's very quick to use, and it gives you feedback about why you've changed things and why things are wrong, what you should do to change them, and how it affects different types of users. And there's a set of links to find more stuff out. So that's basically all I had. The key points really are: this is about you. It may not be about you today, but it could be about you tomorrow. So you will be grateful for all the thought you put in, and the earlier you put that thought in, the better. Really. If you think about a project and the accessibility implications of it at the beginning, it is so much easier, so much cheaper, and so much better than trying to bolt the stuff on afterwards, which I've learned, and I guess many of you have learned, is really painful and really can take projects way, way beyond their expected completion time. So, thank you very much.
I'm waiting for the right signal from the most important person. One moment.
Black screen.
Black screen. It's called Blue Death. It used to be.
No, it's just Hello Darkness, my old friend.
But the first slides, it does not be recorded, so maybe I can start without it before you set it up. So, yes. I'll do some more questionnaire before the technology will allow us. Is there anyone doing DevOps those days? DevOps. Little bit. What about automation, like build systems and running tests, maybe automated way? Anyone? Hey, raise the hands. Don't be ashamed. I see Zdeněk over there. Okay.
I think there is a problem with Mac. Don't. Doesn't matter.
We have a Windows machine backup if we need it. If it's really broken on Mac.
I use the camera to the slide. Recording it here.
We had the plan. Thank you. Start.
Okay.
Ready?
One sec.
Let's do it.
Okay.
Ready?
Sure.
Ready.
Are you sure we're ready?
Like ready or?
Ready?
Ready.
Okay, great. So our topic today is automate everything you can. So let's start with what is automation? Automation is pretty much trying to figure out some kind of manual process that you're doing and making it into bite-sized pieces, looking if it works, and then using some kind of automation to make it automated. So we started with something, let's give it a real-life example to be more realistic. So let's say cleaning. We started with a regular broom, then we upgraded to vacuum cleaners. Now we upgraded to vacuum cleaners that we can use from our phone, where we tell it, okay, clean every Tuesday at 2 p.m. when I'm not home. Tell me when you're done, and that's it. Yeah, or toothbrushes or something like that. But maybe a better example, since we're in Prague, would be beer, right?
Yeah.
What would be the best way to automate?
So we found this beautiful example of smart engineering, actually from Germany, but I think it pretty demonstrates a pretty cool automation, how you can simplify part of Friday evenings or something like that. So the reason why we are bringing examples which are not really super technical, but are actually helpful, is that what this automation is about. It doesn't need to be only purely technical about coding, programming, and everything. It just simplifies your life. And if you save your time, you can spend more time, doing other things, other features for your customers, or maybe go home early and spend more time with your family.
So let's go back to the technical world. We're more comfortable here. So our way to DevOps, how it looked like. It started as 3 different organizations. We had engineers who were doing all the coding. We had QA who did all the testing. And then we had operations who were doing all the deployments, releases, making sure that deployment actually works and stuff like that. How it usually ended up looking is something like this. So the main problem we had is we didn't know who was responsible for the code in the end, who had the ownership over it, and who is accountable for it if it doesn't work or if there's some kind of bug on it. Looking at their process, we saw that potentially there's something wrong, that it could be improved in some way. So we got to where we are now. So something like this.
So it's the DevOps model, where you remember from the previous slide, there are 3 pillars. There's the engineering, there's the QA, and there's the operations. You merge it all in once, and you either scale a team or you put everything on your team. So you have still the team of the same size, but if you look at it, you might look at it the way you have triple more work, right? So then it's a question whether you really need 3 times more people, or you can, put and pick bits and pieces and automate things which are being repeated every day, maybe every week, every 2 weeks, every month, Depends on your business case, on your technical demands, but then they can save the time, and then you can still focus on the important things which are needed.
Another good thing about having one team working on one thing is that it's like a tiny startup. Your team is responsible for the code from the first line of the code till the moment it gets into production. So you know every step of the way how it went, and you're responsible and accountable for every step of the way, which brings a lot more value in the end to our customers as well. So with that, what and why we should automate. So why? It's predictable. So it's a lot easier to predict results if you know all the steps that you're taking. If you know at which step you fail,
PowerPoint crashed.
PowerPoint just crashed, yay! So yeah, if it's predictable, it's easier to know where you failed, and it's a lot easier to know where to start fixing, where to start looking for bugs that maybe came into your application or in your code. If it's automated, it's also a lot easier and quicker to find where it went wrong, because among other things, you can run it whenever you want. It's more reliable. You know that you don't have to count on that one tester to do that one specific test he always does. And if he's sick, you have to wait for him to go back from sick leave. You can actually know that that specific test, you can write it. You know that it will always be done in those specific steps. And it will always be run when you're building and stuff like that. And among other things, it saves time. So if you have a task that you do for 5 minutes every day, in the end it's around an hour in a week, around 5 hours in a month. So if you can automate it, you can save up to 5 hours per month. So if it's something like checking dashboards, like every day you have to go open a dashboard, check what's the metric, if it went down, if it went up. If you have it automated, then it will just alert you if there's some kind of failure or some kind of decrease that you don't expect. That way you can save your time from checking it all the time manually. And in the end, it's fun because you get to play around with other tools that you maybe wouldn't use in your day-to-day life.
Okay. So, on the technical part, what and how you can automate how the software process looks like. You produce a code. You write a code, you Stack Overflow it, you inherit code. There are many different ways, but at the end you do more or less some testing. You either have some automating testing or not. Sometimes you do less, and then you release it. And then the circle goes again, because you want to add more features to your customer. So it's a beautiful circle. And you want to get as effective and as fast usually in those circles. So when there are companies, there are projects even bigger when they ship their increments a couple of times a day, a couple of times an hour. There are some who do that every 2 weeks, month, half a year. Depends on your business. The time is not that important. Important is the effectiveness. So whether you can really use the time you have as effectively as you can to build the increment for your customer, or you will be firefighting all over again because you need to ship something new.
So from that beautiful 3-step circle, in the end, in the background, it's something like this. So usually it's around 5 pillars, let's say. We start with code, where we want to have quality code written. Most of the time you want to have at least some kind of static code analysis. Most editors have it built in now. Before you start building, you want to know on what your application or your project will be run. So if you want to have multiple versions, multiple different types of compilers, how it will work on each build. If you want to test, how does it look like?
So you have start from unit testing, memory leaks, performance testing. Of course, you probably want to track some kind of code coverage and all this kind of stuff. which will be nicely displayed, and you can fail the bill, you can send an email when something goes wrong, you're below the threshold, and so forth, so forth. When all that passes, you probably want to deploy somewhere, like either to the App Store, in case of the mobile apps. Again, we are not talking about services only. Here it can go wide, like you have an app on Android, iOS, it can be serviced in the same time. So you want to probably deploy to some internal ring, so you will test it within your team, within your small organization before it goes live. And you probably don't want to do it in the way that you log into some portal, you get a zip file from somewhere, and you drag and drop it. Maybe you accidentally drop it from, instead of the internal environment, you drag and drop it to production. Oops, what just happened? So you probably want to have, some predictable process which has the boundaries, and you really can do that even if that smartest guy in your team goes on vacation because he just wants to.
And in the end, after you're deploying stuff, it's not done for you or for your customers in the end. You want to know if that thing that you deployed actually works, so that it doesn't happen that you deploy something to production and magically it stops working for everyone. You want to at least know first before your customers start to complain. So having at least some kind of monitor on your services or on your product itself, it's a really good idea. To have some kind of thresholds to know at which point to consider something a failure, and some kind of metrics that you can track to see how is it doing. An example in real life, just to give to go from abstraction to more or less real life. This is how a build release pipeline usually looks on Azure.
So on the first part, we have the bits and pieces which are taking care of the code, just compilation and all this kind of stuff. But then you're interested that you run the integration tests, memory tests, and if it all goes well, you're passing further the steps, and also exactly the gates which I was explaining. So in this case, it just kind of happened that a build ends up accidentally in production. Otherwise, it passes all the steps from the left to right, so there's full control. You can, whenever you look at the dashboard of the pipeline, you see in which states or state the build is, when it got stuck, where it failed, and based on the historic data, you can predict, because you know how much does it take from A to Z, so you can predict how much time does it take today, tomorrow, in a month, in a year. More or less, of course, like it changes based on the product, but you can have rough estimate. If it's 5 minutes, then you know it's more or less 5 minutes every time.
Yeah, so let's step back a bit. So other than looking at builds, releases, code itself, there are other things that can also be automated. We mentioned before tracking metrics like the dashboards. That can be automated. If you have a manual report that you have to give every week where you collect always the same amount of data, you can also automate it in some way. If you have some kind of milestones or time-based events, you can also make reminders in your team. Okay, this is what we have to do in 2 weeks. Just be aware that this will happen. Usually automation doesn't necessarily have to be connected to code, but it's always good to take a step back and consider what processes you have that could be automated in some way.
Yeah, so on this topic, I pretty much like, there's a tool or service from Azure, it's called Logical Apps. And what allows you to do is basically you get an input. Go as wide as you can imagine with input. You process the input and you get an output. And you can automate the workflows. It can connect to your internal business service buses, databases, but it can do much more. So the triggers can be either reoccurring, so every morning. It can be event triggers, so it means stock price increases, or it can be HTTP request. It can be you send a text message somewhere, you receive an email, you upload a file to OneDrive, Dropbox, and then you want to do something with that, right? Or you post a new tweet on the Twitter, so on your company Twitter, and a new tweet saying you know that your product is not the best and customers are expecting some, or they are experiencing some troubles. So then you want to produce an action. You want to analyze what just happened and either like send the email, send the message to your communication channel, or you can actually build in an AI. So if there is a, you know, an example of the Twitter post, so you can analyze the sentiment of the Twitter message, and you can see whether it was rather negative or rather positive. If it's negative, oh, probably there's something wrong, so you want to escalate it higher. If it's positive, all right, nice, we can share it in like user voice, but we are more interested about, let's say, after releases, about the negative sentiment.
The good thing about the Zero Logic apps is that you can plug into pre-existing tools that were built. So you don't have to rebuild how to pick up or how to make a subscription on Twitter whenever a new hashtag with that specific hashtag, a new post shows up. You don't have to figure out how to recognize when a new email gets sent to an email address. It's actually already built in. Like you can just leverage what's already there, and you can fall back on Azure that it will be reliable pretty much, so you don't have to host it anywhere for yourself, which is also pretty useful as well. So we got a few examples.
So one of the examples, it's a shame that Karel left us, but you know, he mentioned this Twitter. So actually in this way, whenever Karel posts a tweet on his Twitter and we check it every 5 minutes, we'll take the tweet and send it over to our channel on Teams. Can be Slack, can be email, can be, you know, SMS or any other channel. So I did all of that in like 5 minutes, all drag and drop, zero code, and it's just two-step scenario, right? So in between, imagine between the post is tweeted and then the message is being sent, you can have the processing. So like, was it negative? Was it about .NET? Paste it there. Was it about, you know, .NET Core? Paste it somewhere else. And you can really start small, like with the baby steps, and increasing as much as it brings value to you and the team, and it's saving you time.
So we mentioned that it doesn't have to be necessarily connected to work or stuff like that. So you can actually check periodically when you're going in the morning for work, what is the current situation with the travel time and how much it will take you to get to work. If you see that it's actually more than your usual 30 minutes that it takes you to work, you can actually automatically send an email to your team like, oh, guys, I'll be late for stand-up, please don't wait for me, or something like similar to that.
Yeah, you know how Czech highways look like probably in the morning, so yeah, this is really handy.
And another more complicated, so it doesn't look like it's only related to social media and stuff like that. So you can actually set up, when you have a build pipeline complete, to check multiple things. Like if it completed successfully, you want to check your dashboard, if everything is okay there, collect metrics on the build. For example, if you want to check if memory went over or something like that, process those results. And if everything is okay, summarize the results and post it into Teams so your team is aware of what is going on. Or if it's not, for us we have an incident system where we have a person that's on call and gets called for stuff if something is really wrong. So if everything is not okay, you can actually create an incident for someone. And if you have on-call system, on-call rotations, you have a designated person who will take care of it. That way, you can see things faster and make sure that you can actually act on them. So, out of all of this, what are the lessons learned? So, there are stuff that can be automated. I think you should always take it with a grain of salt. Consider if it's really, if it will give you any value if you automate it, if it makes sense to automate it. So, you could automate ordering lunch every day, but do you really want to eat pizza every day? Maybe not. So always take into consideration what your process is. Do it in baby steps, go step by step, take a process, break it down, maybe while you're automating it, you actually figure out that you don't need it. And that's actually a pretty good way to figure out if something is obsolete or something needs further improvement. Yeah.
I think you pretty nicely covered and closed the talk. So now we are opening space for questions, and we are all yours. Thank you.
No questions?
No questions? There's one. Shoot.
I have a question on this. So was talking about. Is there a way how I can build some demo of it and present it in my company if I don't have paid Azure account or something like this?
Yep. So you can create a free or trial account where you can try quite a lot of things. Back on the slides, or if you type logical apps, there's a documentation so where you can actually build that the commute example. So there's like really step by step how to build it in, how to test it out, and then you can definitely do the demo.
Yeah.
Or you can get in touch with them, and we can maybe give you coupons so we can get some free credit on it.
Okay, thank you.
Shoot.
Is there also ways to do these apps in a way that you can do Git revision histories, like XML or code?
In the background, this is JSON. So you can have like it in a source repo, so you make sure that it's iterative and that you don't make a bug and not be able to fix it later.
It's like a template at the end of the day where you're describing the step by step. Also the connectors itself, that does not give you what you really need to connect to. There's an API where you can build your own connectors, so you can really build to your own custom service deployment, whatever basically. More questions? All right, so thank you very much for your attention.
Yeah, thank you.
Have a nice rest of the evening, and let's see you by the coffee.